Let's take a look at this intermediate level question related to topic 3, the laws of motion. A 5 kilogram object is placed on a frictionless horizontal table, is connected to a cable that passes over a pulley and then is fastened to a hanging 9 kilogram object, as in the figure. Draw free body diagrams of both objects and find the acceleration of the two objects and the tension in the string. To solve the question, I will be labeling the 5 kilogram as mass 1 or M1, and then the 9 kilogram object as mass 2 or M2. To draw the free body diagram, firstly I'm going to draw the outline of mass 1, which is rested on top of this horizontal table. So now we will be drawing the forces acting on the object. The first one will be the weight. W1 is equal to M1 multiplied with G. Now we're going to substitute mass 1, 5, multiplied with 9.8, the gravitational constant, and it is going to be equal to 49 Newton. Because it is rested on a surface, the horizontal table, it will also experience another force, which is the normal. And normal is going to be perpendicular or 90 degrees to the plane of the surface. So this is going to be normal. And last but not least, because it is attached to this cable, it will also experience another force, which is going to be the tension in the cable. So now the tension is always going to be directed away from the mass. And last but not least, I'll be drawing the direction of the acceleration, which is going to be directed to the right, because rightfully the 5 kilogram mass will be pulled to the right by the 9 kilogram object. Now I'll be drawing the second mass, or mass 2. First, I will be drawing the outline, the block with the string, and then now we'll be drawing the forces. First of all, there will be weight, and then this one will be labeled as W2, and then this is going to be equal to M2 multiplied with G. So mass 2 will be 9 kilogram. So 9 multiplied with 9.8, it is going to be equal to 88.2 Newton. We also have tension going upward or away from the mass. And last but not least, draw the acceleration, which is going to be downward. It is important to understand that the tension here will be the same when it is near to the mass 1 as well as when it is near to mass 2. For reference, we can draw the x and y axis. For mass 1, this is going to be the x and y axis, and this is going to be the x and y axis, which is for our reference. Now we're going to apply the Newton's law for each component of both masses. Let's start with mass 1. So for mass 1, we start with the x component, and then we can see here there will be acceleration along the x component. With that, we're going to be using the second Newton's law of motion, which is the summation of force is equal to ma. The force in the x-axis is going to be the tension in the cable. We only have one force along the x-axis, and then this tension will be the one that produces the acceleration. And then we're going to substitute mass with m1, and the acceleration will be a. Bear in mind that when we substitute the force as well as the acceleration inside of the Newton's second law of motion, we also need to substitute the sign, positive or negative, to show its direction. Because tension is directed on the positive x-axis, it will gain a positive sign. Same goes to acceleration. Moving on, we can substitute the value of mass 1, which is going to be 5 kilogram. So this is going to be our first equation. Moving on now to mass 2. In this case, it is only of a single axis, which is the y-axis. So we have acceleration along the y-axis, so we use the Newton's second law of motion. Total force is equal to ma. There are two forces, so we're going to just write down, we're going to list all of the forces along the y-axis, which is tension as well as W2. We have to add all of the forces together. So T plus with W2, and remember that just like previous, we have to put in the sign according to the direction. So for the tension, it is rightfully positive because the tension is towards the positive y direction. And then plus with negative W2 because it is pointed downward direction or towards the negative y direction. It is equal to, and then because the acceleration is also downward, it will be negative ma, negative m2a. So we can substitute the equation P minus with W2 as calculated 88.2, weight of mass 2 equal to negative 9a. So this will be our second equation. So what we have to do next is solve this simultaneously by substituting equation 1 into equation 2. So T here is equivalent to 5a based from equation 1, and then we're going to write the full expression from the equation 2 minus 88.2, it is equal to negative 9a. So I'm going to bring negative 9 to the left hand side of the equation, so it will be 5a plus with 9a, bringing it to the left hand side of the equation, and then negative 88.2, I'll be putting it at the right hand side of the equation. So it will change its signs from negative 88.2 to positive 88.2. So in the end, it will be 14a is equal to 88.2. And then to find the acceleration, it will be 88.2 over 14. The answer will be A is equal to 6.3 meter per second square.